What if the sun sent a colossal burst of energy directly at Earth? Imagine the consequences of an X8, 7 solar flare, the largest in the current solar cycle. Solar flares are explosive events on the sun's surface, releasing vast amounts of energy. They occur frequently, but vary greatly in intensity. These bursts can light up the Earth's sky with stunning auroras, yet they also have the potential to disrupt technology and power grids. Recently, a superactive monster sunspot unleashed an X8, 7 flare, marking it as the most formidable in this solar cycle. Sunspots are darker, cooler areas on the sun's surface, where intense magnetic fields loop back on themselves, creating tension until they explosively snap, releasing solar flares, the X8. 7 classification places this flare among the strongest observed, capable of significant impact. This particular monster sunspot has been under scrutiny, as it harbors the energy to disrupt our planet's technological framework. Now imagine the vast energy from such a flare heading straight toward us. What happens next? As the solar flare barrels towards Earth, our technology stands directly in the line of fire. Imagine, if you will, a world where at one moment, you're navigating through a city with your GPS, and the next you're left staring at a screen that can't find its way home. This isn't just a minor inconvenience. Solar flares, particularly of the magnitude we're discussing, carry the power to disrupt satellite communications on a grand scale. This includes everything from the GPS services that guide us, to the satellite television many watch, and even the backbone of internet services that connect us. But the effects don't stop at lost signals. These cosmic phenomena can induce electrical currents strong enough to reach the very power lines that light our cities. The result? Potential widespread power outages. Imagine entire cities, regions, or even countries plunged into darkness, not from a storm or a human error, but from a surge emanating from hundreds of millions of miles away. To understand the potential severity of these impacts, let's take a brief look back at history. In 1989, a powerful solar flare struck Earth's magnetic field, triggering a massive blackout across the province of Quebec, Canada. This event left millions without power for approximately 9 hours, and serves as a stark reminder of what could happen. With our reliance on technology only growing, the stakes are higher than ever. Are we prepared for a direct hit from such a powerful solar event? As we delve into the measures currently in place, it's clear that while strides have been made, there are still gaps that need bridging. Governments and organizations globally have developed protocols to shield critical infrastructure like power grids and communication networks from the electromagnetic disturbances caused by solar flares. However, the vulnerabilities are pronounced. Many older satellites and some newer technologies aren't designed to withstand the severe impacts of high-category solar flares. This leaves them susceptible to damage that can disrupt global communication and navigation systems. Efforts are ongoing to enhance our resilience. Scientists and engineers are tirelessly working to develop more robust technologies and improve early warning systems that can provide more timely alerts. Meanwhile, international cooperation plays a pivotal role. Collaborative projects and information sharing among countries help to create a unified strategy to manage and mitigate the risks associated with these celestial disturbances. Preparation is key, but the unpredictable nature of solar activity always leaves room for surprise. As we brace for the effects of solar flares, what can we learn from observing these fiery giants? Peering into the heart of our solar system, recent missions like the Parker Solar Probe and the European Space Agency's Solar Orbiter have been pivotal. These spacecraft are not mere voyagers, they are our eyes in the unfathomable heat of the sun, designed to unravel the secrets of solar dynamics up close. The Parker Solar Probe, launched in 2018, ventures closer to the sun than any previous spacecraft, facing brutal heat and radiation to provide us with unprecedented data. Its primary goal? To trace the flow of energy that heats the solar corona and accelerates the solar wind and solar energetic particles. By understanding these processes, we can begin to predict solar activity with greater accuracy. Similarly, the Solar Orbiter, while it keeps a safer distance, complements this by capturing high-resolution images of the sun's poles. These are regions never seen before, yet crucial for understanding the sun's magnetic field and its influence on solar flares. What do scientists hope to achieve with all this data? A clearer understanding of the patterns and mechanisms behind solar flare production. This isn't just academic curiosity. By mapping the sun's behavior, researchers aim to improve our forecasts of solar activity. which is vital for protecting Earth's technological infrastructure from the devastating impacts of these solar tempests. Every observation helps us understand a bit more, making each solar flare less of a mystery and more of a lesson in cosmic power.